Myself, Dr. Bhat, Assistant Professor from the Department of Chemistry. Today we will start the next lecture, that is Unit 2, Polymeric Materials. In the first lecture we have discussed the introduction and classification of polymers, and in this lecture we will discuss the process of polymerization and the types of polymerization, that is addition polymerization, condensation polymerization and copolymerization. In this lecture we will discuss about polymerization and addition polymerization. The contents of today's lecture is what is polymerization, and we will discuss about addition polymerization. Then in the next lecture we will discuss the condensation polymerization and copolymerization. So we will start with the definition and introduction of polymerization. The process of polymerization is in which smallest units of monomers combine together to form large macromolecules, that is known what we call as polymers. And the process of the formation of polymers from smallest units, that is monomers, is known what we call as polymerization. These monomers are combined through covalent bonds, and the process is known what we call as polymerization. Here we have the types of polymerization on the basis in which monomers combine together through covalent bonds. First we have addition polymerization. Then the second type is condensation polymerization, and the third one is copolymerization. So we will start with the first type, that is addition polymerization. The polymerization is in which bifunctional monomers which has two active sites, or we can say has two functional groups. FG means functional groups. They combine to form polymers by the reaction that is known what we call as addition reaction. In addition polymerization, there is no elimination of byproducts. It is also known as chain growth polymerization. So we can say the definition: the polymerization in which bifunctional group, biactive sites, monomers combine together without the elimination of byproduct through chemical bonds and results in the formation of polymers. That process of polymer formation is known what we call as addition polymerization. It is also known as chain growth polymer. The main features of addition polymerization is this polymerization takes place between two monomers that are bifunctional, which has two active sites, or we can say two functional groups that combine without the elimination of byproducts. Several bifunctional monomers are combining to form polymers without the elimination of byproducts. This polymerization results in the formation of linear polymers. We can say by addition polymerization, the resultant polymer is linear. It results in the formation of linear polymers. The produced polymer, that is known what we call as linear polymer, has same chemical composition as that of the monomers. The molecular weight of polymer is an integral multiplier of monomer units. Examples are polyethylene, polystyrene, polyvinyl chloride and Teflon. These are certain examples of addition polymerization. So we will discuss them one by one. First, the addition polymerization of polyvinyl chloride. See here, this is vinyl chloride, that is the monomer unit, which has two active sites, and these monomer units combine by addition polymerization without the elimination of byproduct. Results in the formation of large macromolecules, that is known what we call as polymers. It is polyvinyl chloride. And vinyl chloride monomers combine together by the process of addition polymerization and results in the formation of polymer, that is polyvinyl chloride. What are the properties of this polyvinyl chloride? Polyvinyl chloride is colorless, non-inflammable and is chemically inert. The specific gravity of polyvinyl chloride is 133 and its melting point is 148 degrees centigrade. Polyvinyl chloride is a very strong addition polymer or linear polymer and is brittle. This polyvinyl chloride is very resistant to the various atmospheric conditions. The polyvinyl chloride is not stable to heat and ultraviolet radiations. What are the different applications of these polyvinyl chlorides in the engineering field? Polyvinyl chloride is used in electrical insulations and it is also used in cameras and aircrafts. Polyvinyl chloride is used in articles, radios and telephones. We can use polyvinyl chlorides in helmets, fridges and tires. The second type is polymerization of styrene, in which different styrene monomer units combine together by the process of addition polymerization through covalent bonds to form polystyrene like this. These are styrene monomer units. It undergoes addition polymerization without the elimination of the byproduct and form large molecular weight polymers, that is known as polystyrene. What are the properties of polystyrene? The properties of polystyrene is it is very hard and is transparent. This polystyrene is formed by the polymerization of styrene monomer units. Styrene monomer units and has been widely used plastic At room temperature, if we see, the thermoplastic polymer is solid, but when it is heated above 100 degrees centigrade, it flows. Yani above 100 degrees centigrade, it is not stable, it can flow. It becomes, but it has a property of thermoplastics. Yani on cooling, it can again becomes rigid. Polystyrene is insoluble in water. It cannot be dissolved in water. It is very insoluble. Polystyrene is a compound that is non-biodegradable with couple of exceptions. Yani ki certain types of polystyrene plastics are biodegradable, but most of the time it is non-biodegradable. It is easily dissolved by many aromatic hydrocarbon solvents. And if we take the aromatic hydrocarbon solvents, the polystyrene can be dissolved, and it is also dissolvable in chlorinated solvents. The polyvinyl chloride is widely used in food service industries as rigid trays, containers, disposable eating plates and bowls. There are certain types of uses of these polystyrene plastics or polymers. Medically, it has its importance for sterilizing test tubes. We can sterilize test tubes and diagnostic components and other medical devices. It is used in the manufacture of car parts, which includes knobs, instrument panels, sound damping foam. Polystyrene can also be used for various types of food services like packaging that keeps the food fresh, and food should be kept for longer periods in these polystyrene polymers. It is also very less expensive. These polystyrene polymers can be used for packaging various types of goods such as DVD cases, egg cartons to protect against spillage and damage. These polystyrene polymers also provide thermal insulation and can be used in refrigerators and freezers. These polystyrene polymers can also be used in housing in all IT equipment such as television and computers. Then there is one more addition polymer that is known what we call as Teflon. The Teflon was first discovered in 1938 by Roy Plunkett. He was an American chemist. This Teflon is defined as a synthetic fluoropolymer. It is a synthetic fluoropolymer that is formed by the addition polymerization of tetrafluoroethylene monomer. Tetrafluoroethylene monomer. Tetra means there are 4 fluorine atoms and double bond is there, that means ethylene. We can say it as tetra. Tetra means 4 fluorine, tetrafluoroethylene. These monomers combined together by addition polymerization forms Teflon. By these repeating units of tetrafluoropolymer, or we can say tetrafluoroethylene. These tetrafluoroethylene monomer repeating units combined together by addition polymerization results in the formation what we call as Teflon. The properties of Teflon is that it is thermoplastic polymer. The chemical formula of Teflon is C2H-F4, and these are the ethylene tetrafluoroethylene monomers oblique N times, yani N times tetrafluoroethylene monomers combined together to form Teflon. The Teflon formula shows a repetitive or N number of tetrafluoroethylene units. Teflon has the ability to maintain high strength, its toughness is high, and it acts as a self-lubrication at very low temperature around 5 Kelvin. The Teflon has a good flexibility at temperature above 194 Kelvin. Uses of Teflon. The Teflon is used in making waterproof fabrics. We can use Teflon in making non-sticky stick clothware. It can also be used in making anti-friction devices. The Teflon can also be used in coating of medical appliances like surgical devices. Yani ki most of the surgical devices have been coated by Teflon. Teflon is very high resistant to corrosion. It is used for coating the lining of laboratory appliances. Now we will discuss the mechanism of addition polymerization. Yani ki what is the mechanism of addition polymerization? Based on the formation of reactive intermediates like free radicals, carbocation and carbon anion. In addition polymerization can be classified into following types. The first one is free radical mechanism, second is cationic mechanism, and third one is anionic mechanism. We will discuss first the free radical mechanism, and there are three types of mechanism for addition polymerization. One is free radical addition polymerization, carbocation addition polymerization, carbon anion addition polymer. But here we will discuss the free radical polymerization. In free radical polymerization, the monomer is first converted into a radical by the action of light or heat, or we can add certain types of chemicals. These chemicals that have been added to initiate the reaction are known what we call as initiators. Initiators initiate the first monomer of polymerization process. Example, we will take benzyl peroxide. The chemical formula of benzyl peroxide is C6H5 C double bond COO C6H5. Hydrogen peroxide we use here. The chemical formula of hydrogen peroxide is H2O2. For free radical polymerization, in every mechanism, the following steps are involved. First is initiation, chain initiation. The second is chain propagation, and third one is the termination of the chain. The first one is chain initiation, that is we use the initiator, that is benzyl peroxide. Initiator initiates itself in the presence of light, then the initiator initiates the first monomer to form radical. A variety of alkenes and their derivatives are polymerized in the presence of free radical generating initiators like benzyl peroxide. We can use acetyl peroxide. We can use tert butyl peroxide. For example, the polymerization of ethylene to polyethylene consists of heating or exposing to the light a mixture of ethene with a small amount of benzyl peroxide. Benzyl peroxide here is used as an initiator in the presence of the light to combine different monomers of ethene to form the polymer that is known what we call as polyethylene. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating new and large free radicals. This step is called chain initiating step. As this radical reacts with another molecule of ethene, another big sized radical is formed. This process goes on through repetitive additions in the sequence with new bigger radicals carries the reaction forward and the step is then terminated, that is known what we call as chain propagating step. Ultimately, at some stage, the product radical thus formed reacts with another radical to form polymerized product. This is the last step of the formation of polymers, that is known what we call as chain terminating steps. Just like we will take the example of vinyl chloride into polyvinyl chloride. The second one is vinyl cyanide into polyvinyl cyanide. We can transfer styrene monomer units into polystyrene. We can form polyethylene from the ethylene monomers. The first process of the mechanism of addition polymerization starts with the formation of phenyl radical. We take benzyl peroxide and the bond is broken in between to form phenyl radicals. These phenyl radicals are formed, then this phenyl radical reacts with ethylene monomer units, C6H5 radical reacts with ethylene monomer units to form the radical, first radical. Chain propagation. The first step is the initiation of the polymerization reaction. Then there is the repetitive additions of different radicals to form the chain. In chain propagation, more number are added to active radical chain initiators to form macro new radicals like this. These are the radicals. It will combine with the second monomer unit molecules. By this repetitive additions, we form bigger, large monomer radicals, large macro or large radicals we call them. Then there is a chain termination. In chain termination is done either by coupling of same free radicals or by disproportionation. First is the coupling termination. Two molecules of macro radicals that are formed by the repetitive addition of monomer units with the radical to form macro radicals. These macro radicals combine to give meaningful polymer, or we can say the dead polymer, yani ki chain, that we can say the chain termination polymer. like this. These micro radicals combine together to form polyethylene polymer. We can say as polymer. This polymer is formed by the addition or by the combination of micro radicals. These are some of the textbooks that I have consulted while preparing this PPT. If you want to get the more knowledge about the process of polymerization and the addition polymerization and the complete understanding of the mechanism of this mechanism of addition polymerization, you have to consult these reference books for that. So today's lecture was about polymerization and the type that is known what we call as addition polymerization, and we have discussed here the mechanism of addition polymerization. This is not the end. See you very soon in the next lecture. Thank you very much for your kind cooperation. Thank you.